Hello, welcome back to fractions. Here we're going to take a look at addition of fractions. We'll start off with 2/3 plus 1/2. So first, let's take a look at the Cuisenaire rods here. So here I'm using the dark green one to represent a whole. And so you can see the red is a third, and the green represents a half. And so here, I'm going to combine. So you got to, in order to do addition with anything or subtraction, you got to know two things. One, what does addition mean in the context of the objects that you're playing with? So we know what a fraction is. Our most common definition of fraction is a part of a whole. Addition means to combine and then count them. So let's do it. So 2/3 plus a half is more than one whole. So now we got to figure out how much more. What do we call this new object? Okay. Well, we need something that is commensurable with the two other units. And so what is that going to be? Well, looking back at all my Cuisenaire rods here, the little white one is probably what we're going to go for. So let's try. So I've got 3 whites make a green, and 2 whites make a red. So then rebuilding my 2/3 plus 1/2 with whites, I get, so what we can see here when we do our comparison, let's move our whole unit to the other side, is that 2/3 plus 1/2 gives us 1, 2, 3, 4, 5, 6, 7 equal sized pieces. And there are 1, 2, 3, 4, 5, 6 in a whole. So according to this, our answer for 2/3 plus a half appears to be 7/6. Or, we know that 6 of these make a whole, and then that one extra one says I have a whole, and then 1/6 left over. So there's another way to write it as 1 and 1/6. Oops, pointing to the wrong spot. Thank you, cameraman. Which we often abbreviate without the plus sign, but we still say 1 and 1/6. Let's take a look at that with another set of toys, pattern blocks. So pattern blocks, let's use that as a whole this time. Now that's one thing you want to be careful of with young kids in similar time frames, is switching back and forth between this is a whole, now 2 of them's a whole. That can be confusing. So for a while you would just have that as a whole and do what you can with it, then move on to something else. So a red is a half, and a blue rhombus is 1/3. You can see here there's a second third, and then the third third's right there. Now when I try to put them together, the problem is, again, a half and a third, even with these pieces, are not commensurable. So let's try to put them together. Now if you take a look at that, that is greater than a whole. Cute, huh? Also, I get a neat new shape when I put those together. It's got 1, 2, 3, 4, 5 sides. Interesting. So, common denominator here is going to be these green pieces. And so, from earlier work, we know that 6 of these green guys make a whole. I have foam versions of these. They're a little easier to handle, but they're lighter. But the colors are different. Okay, so there's a whole. 6 pieces plus 1/7 piece makes my 2/3 plus 1/2. So again, I'm verifying that 7/6 with these toys, or you could look at it as 1 and 1/6 when put together. So multiple options for the answer. You can go with your improper fraction, that beautiful 7/6 there, or 1 and a sixth, the mixed number. Let's take a look at my cakes here. And I mentioned cakes are better than pies. A pie would be a circle, I think, for working with these things. So I have 2/3 that are of interest in this cake and 1/2 of this cake over there. And I want to combine them, put them together. Okay, so we take our groups, refocus, and then the trick with the cakes is to cut each cake like the other. So I take the thirds cake and I cut it in half, and I take the halves cake and I cut it in thirds. Notice my perpendicular directions. Now I have a new cake that is cut into sixths. How many sixths? Well, I can just count. 1, 2, 3, 4, 5, 6, 7 equal-sized pieces, and 6 of them make a whole. This also shows me that 2/3 can be written as 1, 2, 3, 4 out of 6, and 1/2 can be written 3 out of 6. So there are many ways to work with fractions. You can build fractions from 1/2 to 3/6. You can also use cakes like this to combine, to merge, and take 3/6 into 1/2. So with these toys, you can teach not only comparability of fractions, you can teach how to build and reduce fractions, which is a very important skill. Try another one. 3/4 and 1/6. So I'm going to do this one a couple of different ways. So first, I am going, now we could use the pattern blocks for this, we could use the fraction strips for this, but I am going to use my cakes. And what I'm going to do is the same routine that I did before. I'm going to cut each cake like the other, because the problem is I have 3 of these guys and I have 1 of those guys, but the problem is these 3 things are an entirely different shape than 1 of those guys over there. Okay, so they're not comparable, they're not commensurable. So cutting each cake like the other, I'm going to cut this guy into sixths to the best of my ability. Cut this one into fourths, which usually cut it in half and then in half again. It's close enough. Okay, so now I have a new cake cut into a new set. So let's see, it's what? 4 by 6, which means I have 12ths. Now how many 12ths do I have? Well, in this cake over here, I have 3 columns and 6 rows, which gives me 18, 19, 20, 21, 22 pieces total when I regroup them. Now, you could put that together in a whole new cake and see what happens, which can be fun. Maybe we should do that. So building a new cake, I can put 12 of them in here. Oops, I can't count. That's 24, sorry. Glad somebody was paying attention out there. 4 times 6 is not 12. It is 24. Let's put them in the cake. One, 2, 3, 4, 5, 6. Okay. And I have 22 of those. So that's this row, this row, this row, and then 1, 2, 3, 4 going on there. Okay. Now if I regroup just a little bit different to see how significant that 2 is, I can look for other groups of 2 in here. And regrouping this way, I can see I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 out of 4 by 3 out of 12. So there's another representation of this answer besides 22 24ths. Often we like the reduced answer, which is kind of nice. Okay, so putting those together into a new pan can sometimes help me find a different representation of the answer.